All right, everybody. We had requests for about 3 more. We're going to do 1 more today and start next on tomorrow's review day with the other one. I'm going to show you what I meant earlier about learning mechanisms from examples. So we're going to look at the thing we need to do. And here it is. And it's an Edman degradation. Anytime you see phenyl isothiocyanate, it's an Edman degradation. I'm going to go show you where the best version of the Edman degradation mechanism is. I have to be very careful here. Stop share here. Start share here. Where did I put it? Here. Google. I think here. I had it open on another screen.
So there.
I'm sorry. I'm trying to find it.
It's okay. There was actually a really good video on this one already posted. But
Yeah. Want to just skip it then?
no, I don't know who asked unless someone needs it.
I had the sample mechanism. Oh, here we go. I found it. But this is good, helpful to show you where to go. These mechanisms supersede all previous mechanisms for cyanogen bromide, DCC coupling, and Edman degradation. I found them in section 13. It's right above 14. It must be 13. It's at the bottom.
Yeah, did we do a DCC coupling one?
No, what we did maybe an hour ago.
Okay.
And it was one of the ones I want you to learn. They're all the 3 big ones for this test that didn't do in class, but you're responsible for all are here. I'm gonna go grab the Edman one.
Okay.
Don't know if they're in order. Just DCC first. Cyanogen bromides first, DCC's there, and I'm gonna blow up the old Edman. There it is. See if I can get everything and snip it, bring it over and use it as a guide. I know you can't do that on the test, but this is how you get ready for your test. There we go. And this is where I screwed up one time and had to redo a video. I have to stop share on this screen. Reshare on the starboard screen. Where are you, starboard screen? There. I hope you're looking at, did I just draw a whole bunch of mess?
Yes.
Okay, that was the screen. Now I'm gonna put, try. That's my guide. I'm gonna shrink down a little bit. Take it off into the corner. So what's my first step in the Edman mechanism? It looks like we're gonna, red first, blue second. We're gonna attack using the nitrogen on the amine. We're going to attack the carbon and put a lone pair on the nitrogen. Carbon, lone pair on nitrogen. Looks like this NH2 here is this NH here. So we don't have, never have to change to the right there. Everything up to, but not including the NH, is going to be circled and called R. No R's elsewhere on this page. Good. Lone pair on nitrogen is going to attack the carbon way up there. And we dump the electrons. And there's a reason why they go to the N and not the S. 3.0 versus 2.5. I hope you know what those numbers are talking about. And then the N minus that you made is going to grab the H from the nitrogen there. No, it says intermol. Yeah, I can't reach. They'd be adjacent to each other. So yeah, I need to show an H off of my nitrogen. I don't like the color choice because it looked like the lone pair was erased. Wow. Thank you. Flash. Scribble it out. Put an H there, another H there. Still see the lone pair. And the lone pair on the N, which there is one already, come back and grab blue Oh, in French. A little culture doesn't hurt anybody. Oh, obliterated my lone pair. The thicker pen has its drawbacks.
Intermol.
Yes, we need the intermol. This time I got a lot of room to write on it. The big arrow. There you go. And that gets us to this intermediate down here. So what can we copy and what do we have to change? Well, change this isopropyl up there. Yeah. Your isopropyl in yours is this group here. It kind of looks like an isopropyl, but one of the ends is an OH. It's ladies and gentlemen, want to help yourself out. These are all going to be OHs when you're done, right? And that's this molecule pretty much. Okay, so draw everything here except for this is going to be an OH. So what do we got? We got a black arrow saying we made this thing. We got a nice purple molecule. Got a phenyl with an N and a lone pair and an H. And it comes to a C double bond to S. And it has an N with an H. And it has goes to a C that has a OH and a methyl on the same carbon. Comes to a carbonyl, goes to NH, and R is blue. Sure. Yeah, this came from the reagent. This came from the nitrogen we just used up here. That's the group attached to the carbon adjacent. There's the carbonyl attached. NH to the R. Okay. Got to resonate and attach. We're going to make a ring. Sulfur ring. Even though sulfur's not in the ring here, you have to make a sulfur ring in the mechanism. That is cool. You're going to make a sulfur ring and it'll open the sulfur ring. I think we've seen stuff like that before. Resonate. Sulfur attacks the carbonyl across. Electrons come up. Then they come back. In blue. And they hoof off NHR prime. In this case, we don't have water. Are you going to give up because we don't have water? Or are you just going to use ethanol instead? You're going to use ethanol instead. Don't give up. Okay, so HO ethanol is our source of a proton that we're going to use right now. We'll put it over underneath an arrow. HOET in black. HOET. And that's coming off in baby blue and protonating as you go. Might have to move my little box. We have a phenyl erased off the screen, but that's not going to tell me. We need more room to work. We're going to draw this intermediate. Except OH up here instead of isopropyl. So we got, what do we got? We got purple. We have H bonded to N with a phenyl. Double bond and a plus charge. And we have a sulfur. And on the other side, we have NH. Plus a C that has an OH and a methyl. And goes to a carbonyl. It's attached to the sulfur. Not pretty, but it's got everything we need. And the OH minus that you just made looks like it's going to do a deal. It's not an HO minus, is it? It's a OET minus. It is taking the place of HO minus. And it's an attacker to open up the ring. So it attacks, pi breaks, and then the ring opens up. Back. Pi breaks. Lone pair comes back. You get a thionyl. sulfur double bond to carbon is a thionyl. You knew that. And let's keep moving to the right here. This is fun. What did we just make? What have we wrought? All right, we have, we've made this thing, correct? Yes. Copy it, except there's an OH up here. And purple. We have a S double bond C to an N with an H. And it goes to a S double bond C, and also goes to a C with an OH and a methyl. And the C here has carboxylic acid attached. And what else we got? That's an H foot. And H lone pair foot. And you are here. Lone pair is going to attack carbonyl. I is going to break. Lone pair comes back and hoofs off OH minus.
It's actually OET, but it's fine.
Oh, you're right. It's OET. See? Busted. Yeah, I just copied. I'll even put it in black. Easier to keep track of. That's what came from. OET. And it got hoofed off right now. So OET minus is a catalyst, isn't it? Until we need it as a base, which is very soon. I don't think I need to move my box anymore because we can wander up here. And we got to copy this species right here, and we're done. Well, we got to do the acid base, but we're done after that. Right.
Yeah, I think if you just do like a purple step and get the H.
I can do the purple now.
A third step, a third
Oh,
step.
yeah. Can't use purple. My molecule is purple. I know. Your points are all taken. Let's make a proper start here. Red first. Blue second. Gray third. Why not? Because you made OET minus. Just put that off of an arrow here, maybe. OET minus, and feel free to use it instead of drawing another intermediate. Go gray. Said nobody ever. I think Army. Army's gray. So they would take over. Might have that wrong. Apologies to the team that is great. And move it on over. I'm going to get rid of the guide now so that when you print this, it'll be bigger, or it'll be bigger on your screen. The guide's just making everything small. So bye-bye, guide. And that's all we have time for today. But just so you know what's coming up Monday, which is tomorrow, we're going to do part B from the same question, which is the cyanogen bromide. Unless you tell me I don't need to do it. And
I don't think you need to do it because there is already
okay. And then
a really good video on it.
you probably use for that too.
And I mean, I know it like the back of my head, and that's not to say I'm going to know it during the exam.
Yeah, but we might, I mean, we could do it again, but
Yeah.
I hope the people that think they needed to do it, tonight they try doing what we just did as a strategy for this one with the guide there.
Yeah.
And go and do it, and then say, I really don't need him to do a video now, because he's just going to do the same thing he did in class, and he's going to put the cyanogen bromide one here, and the arrows are always the same. And there, and then we're going to do, we're also going to do this one, which is a good one. It's a phosphatidylinositol. And I remind you what inositol is here, and then hydrolysis. And that was the end of the requests for today. So we almost got through almost all of them. And we'll see you tomorrow. Got any last minute questions?
No, I really, really appreciate it. We actually had a a very close friend passed from a motorcycle accident last night.
Oh, I'm sorry to hear that.
That's okay. Their funeral is going to be Monday, but it's probably going to be after class, so I will be in class.
It's been a hard semester, hasn't it?
Yeah, I'm getting it. I'm getting through it. Thank you. I really
You've had a
appreciate
lot.
your time.
All right. We'll see you guys.
See you Monday. Bye.
Take care.